Welcome, grade 12, to Tutorbox live in conjunction with COVID-19 classes session 1. Right. So, guys, before we start, I just want to show you this code here. I don't know if you can see it. Okay, just quickly read it. So it says, without a plan, you're going to stay where you are. It's time to make a move. Right. So, guys, if you want to succeed, if you want to pass this year, you need to get up, you need to get your books, and you need to start reading. Okay. So let's start with today's work.
7. Trust me, guys, you do not want to be that guy at the end of this year. You just do not want. You do not want. Okay, so let's just do some work. Welcome, grade 12s, to Tutorbox live in conjunction with COVID-19 catch-up courses, and it's your girl, Lisa, the maths tutor. Okay, so today we're going to be doing some arithmetic sequences, quadratic sequences, and geometric sequences. So arithmetic and quadratic, that's basically recap, and then we're just going to touch up on geometric sequences because that's grade 12 stuff. Okay, right. So in earlier grades, we learned about number patterns, which included linear sequences with a common difference, that's like grade 10 stuff, and quadratic sequences with a common second difference, that's grade 12. We also looked at completing a sequence and how to determine the general term of a sequence. Okay, so now in this chapter, we'll also look at geometric sequences, which have a constant ratio between consecutive terms. We will learn about arithmetic and geometric series, which are the summing of the terms and sequences. Right. Okay, so let's start with arithmetic sequences. So what are these, guys? An arithmetic sequence is a sequence where consecutive terms are calculated by adding a constant. Please note, guys, so you're adding a constant value, so it can be positive or negative, to the previous term, right? We call this constant value the common difference. This is NB here, common difference, okay? And then it's denoted by like a small d there, right? So let's look at this example quickly. We have 3. This is our first term there, 3, 0, minus 3, minus 6, minus 9, and so on, right? So this is an arithmetic sequence because we add minus 3 to each term to get the next term, right? Let's see how I did that there, right? Here's a nice table for you guys. So the first term, T1, is 3 there, right? The second term, T2, was 0. Okay, so let's see what we did there. So we have 3 plus minus 3 gave us 0, right? So you see that our common difference was actually minus 3, right? And then if you think about it this way, for you to move from 3 to the 0, you actually have to subtract a 3, right? So that's why the difference is minus 3, okay? And then for the third term, which is T3, we have 0 plus minus 3, that gives us minus 3. The fourth term, we have minus 6. The fifth term, we have minus 9. Okay, so if I go back here, I have 3, 0, minus 3, minus 6, minus 9. Okay, so you see here I'm adding, let me just go back here. There we go. So I'm adding minus 3, minus 3, minus 3, minus 3 to each term. Okay. Now, let's look at this exercise. It says find the common difference and write down the next 3 terms of the sequence. So we're still finding the common difference. Common difference, remember that's our D there. So common difference is basically the difference between this certain term and that certain term, first, second, third, fourth, fifth, and so on, right? So it says find the common difference and write down the next 3 terms of the sequence. So we have 2, from 2 it goes to 6, 6 it goes to 10, 10 it goes to 14, 14 it goes to 18, 18 it goes to 22, and so on. Right, so to get my common difference, what I'm going to do is I'm going to say, okay, let me take the second term, right, and I subtract the first term. If I take the second term, I subtract the first term. 6 minus 2, I get 4. Okay, so let me check whether this difference is the same throughout all the other terms, right? So now let me test with the third term minus the second term. So D will be equal to 10 minus the 6, and then I get 4. Okay, so you see now there's a common difference. The common difference is 4. Okay, and then it says, and write down the next 3 terms of the sequence. So we want to find the next 3 terms. So this is term 1, the first term here. So that'll be T1. So above 2, you can just put like a T1 there. And then above the 6, that will be the second term. You can just put a T2 there, T3, T4, T5, T6. So we need to write down T7, T8, and T9. T means term, guys, and then that little number there shows you which term are you referring to. So they want T7, T8, and T9. Okay, so we found out that our common difference was 4, right? So we're adding 4 to get the next term. So we're now here at the 6th term, which is 22 there, and then they asked us to get the next term, which is the 7th term. So we're just going to say 22 plus 4, and then we get 26, right? And then now to go to the 8th term, you take the one before that, which is T7, we add 4, we get 30. T9, you do the same thing, 30 plus 4, you get 34. All right, so next up, let's look at exercise 2. So exercise 2, they gave us some negatives there. So we have -1, -4, -7, -10, -13, -16, and so on, right? So we also need to get the common difference, right? Okay, so we check. Let's start off with the second term, which is -4 there, and then our first term is -1, right? So we want to get the common difference. So we're going to say -4 minus -1, right? And then we get -3, okay? And then to check if that common difference applies throughout, so we're going to take our -7 there, which is our third term. And then we're going to subtract -4 there. Okay, so this becomes -4 minus -4. Okay, and then guys, please remember that when you have a negative outside and it's multiplying a negative, this becomes a positive. So this is why it became -4 plus 1, and then that's how we got the -3, in case you're wondering. And then here we have -7 minus -4. These two will multiply, this becomes a plus there. So this becomes -7 plus 4. That's how we got the -3. Okay, so that means the common difference is actually -3 for everything there. Okay, so to get any term, we're just going to add our -3, right? So let's just count. This is term 1, this is 2, this is 3, this is 4, this is 5, this is 6. So they asked us to get 7, 8, and 9, just like the previous example. Okay, so at 6, we're at -16. We want to go to the 7th term. We're just going to add our -3. So remember here we have a plus and a minus, a plus and a minus, that will become a -3. Okay, so that's why it's -16 minus 3, we get -19. We do the same thing for the 8th term. We have -19 minus 3, we get -22. The 9th term, we have -22 minus 3, we get -25. Right, and then let's look at this one. This is sort of interesting, but let's see. So exercise 3, we're still doing the same thing. We need to get the 7th term, the 8th term, and the 9th term. Okay, so now they didn't give us numbers, guys. They gave us letters, variables. What is going on? Okay, let's look at it. So our first term now is a minus 3b. Our second term is a minus b. Our third term is a plus b. Our fourth term is a plus 3b. Okay, same thing, guys. Don't panic just because they're now variables and there are no numbers. Don't panic. It's very easy. Okay, so all you have to do is, let's just get the common difference. Let's see what the common difference is. Okay, so we apply the same concept. So we take T2. T2 is now a minus b. Okay, so I put it in brackets there. So it's a minus b to show that a minus b is just like one whole expression together, right? It's the second term, right? So I put it as a minus b in a bracket. And then we're subtracting the first term, which is a minus 3b, okay? Because a minus 3b is a term by itself. So that's why I also put it in brackets. So this will equal to a minus b, right? We have this minus here. It's multiplying everything in this bracket, okay? Remember grade 10 work, guys. So we have minus a times this a here. We get our minus a, and then minus a times this minus 3b. That will give us a plus 3b, okay? Then if we simplify this further, with a minus a there, that will be 0, minus b plus 3b, that will give us 2b. Okay, see? It's not hard. Or let's just double check to see whether we're correct. So now let's take the third term, which is a plus b, there I put it in brackets again, minus the second term, which is a minus b. Okay, so we do the same thing. With a plus b, minus times the a will give us minus a, minus times the minus b will give us a plus b. Guys, there's a 1 here in case some of you are wondering like what's happening. There's a minus 1 here. Okay, there's a 1 there. Okay, so you can think of it as minus 1 times a if it's easier for you, right? So then we get a plus b minus a plus b, and then if we simplify further with a minus a, that's 0, and then plus b, that gives us 2b. Okay, so the common difference you see as 2b there. So they asked us to get the fifth term, the sixth, and the seventh, right? So to get the fifth term, we're just going to take the fourth term, which is a plus 3b, and we're going to add 2b, and we get a plus 5b. For the sixth, we take the fifth, we have a plus 5b, we add 2b, we get 7b. For the seventh, we have a plus 7b, and we add 2b, and we get 9b. So now the general term for an arithmetic sequence. So where are we getting this formula from? So let's just recap on that. So for a general arithmetic sequence with first term a and a common difference d, we can generate the following, right? So our first term there, that would be our a, right? And then to get to the second term, we take the first term and we add d. So that would be a plus d. Remember, because t1 is equal to a. And then for the third term, we'll take the second term there. That'll be equal to t2 plus d. Remember, t2 here we got as a plus d. So that'll be a plus d plus the d there. And then we get a plus 2d. Okay. And it continues and so on up until we get to tn. Right. So tn now will be equal to tn minus 1. Because this tn minus 1 is coming from the previous term, the term before tn, right? And then we're going to add our d there. So this will be equal to a plus bracket n minus 2 bracket d, and then we add our d. And then if we simplify this guy here, we get a plus n minus 1, all that in brackets multiplied by d. Therefore, the general formula for the nth term of an arithmetic sequence is tn is equal to a plus open bracket n minus 1 close bracket d. Okay, so tn, that's the nth term, a is the first term, d is the common difference. Arithmetic sequence is an ordered set of numbers in which each new term is calculated by adding a constant value to the previous term, right? Constant value or common difference, right? So tn will be equal to a plus n minus 1 times d, where tn is the nth term. We just say that. And now, guys, please understand this part. So n is the position of the term in the sequence, right? So if they tell you that n maybe is 2, that means they want the second position, right? Or 3 or 4 or whatever, right? So n is the position of the term in the sequence. Okay, this n here, that little n there, is the position of the term. And then with a is the first term and d is the common difference. Okay, so to test for an arithmetic sequence, to test whether a sequence is an arithmetic sequence or not, check if the difference between any two consecutive terms is constant. We've done this before. So your common difference should basically be equal to T2 minus T1. It should also be equal to T3 minus T2, Tn minus Tn. So basically what this is saying is, if you're given a certain sequence, right, and then you want to check the common difference, right? So the common difference between T2 and T1 should be equal to the common difference between T3 and T2 and Tn and Tn minus 1. Okay, and if this is not true, then the sequence is not an arithmetic sequence. Right, and then now let's do an example. I think this should be our last example on this. So we are given the sequence minus 15, minus 11, minus 7, and it goes all the way to 173. So it stops at 173. Okay, so our first term is minus 15, right? Second term is minus 11. Third term is minus 17. This one, however, we don't know what term that is. So we're going to call it nth term. Okay, so let's see what the questions are asking. It says, question 1, is this an arithmetic sequence? Guys, remember arithmetic sequence. This should be like buzzing in your head right now. Arithmetic sequence, common difference. Okay, common difference. So this is an arithmetic sequence if we have a common difference. Okay, and then 2, find the formula of the general term. And then 3, determine the number of terms in the sequence. Okay, let's look at that. So for number 1, check if there's a common difference between the successive terms. So we have T2 minus T1, minus 11, minus 15, right? Minus 11, this one, minus 15. And then we get 4. And then if we also do T3 minus T2, we also get 4. So therefore, it's an arithmetic sequence because we have a common difference of 4. Now they say determine the formula for the general term. So write down the formula and the known values. Our formula is Tn is equal to a plus n minus 1, and then we're multiplying that by d. So we know what a is. It's minus 15. There we go, right? And then we know what d is, which is 4. We just calculated it. So n is minus 15, d is 4. We take our formula, right? Tn is equal to a plus n minus 1 multiplied by d. A is minus 15. We substitute it there, minus 15 plus n minus 1. Right, and then d there is 4. We substitute it there, and then if we simplify this, we get 4n minus 19. So this is the general term. When they ask for the formula for the general term, make sure that you leave it in terms of that n there. Okay, right, and then the third question was saying determine the number of terms in the sequence. Okay. So we had Tn was equal to a plus n minus 1, and then bracket d there. So we know what a is, we know what d is, right? And then now it says determine the number of terms, right? So what we know is the nth term. Remember, if I go back, I explained this. Let me just, yes, there we go. So the nth term, because we don't know, this is the first term, second term, third term. We don't know what this is. It can be maybe the 50th term, the 60th term, we don't know. So that's why we're calling it the nth term, right? So, okay. So now our nth term there will be 173. So I'm going to replace that Tn with 173. This will equal to a plus bracket n minus 1 d, right? This is 4n minus 19. I took it from the answer for question 2. And then I have 192 is equal to 4n. I want to solve for n, right? I want to solve for n. So then I get my n to be 48 there, right? Okay, so the 48th term is 173, right? And then now they're asking how many terms are in the sequence. So the first term was minus 15. The second term was, let's go back, minus 11. The third term was minus 7. And the 48th term was 173. So that means that there are 48 terms in the sequence. Time to stretch, guys. Let's bring it in together. Okay. To the wait. To the right. To the left. Forward. Backwards. Breathe in. Breathe out. Okay. Let's look at arithmetic mean. It says the arithmetic mean between two numbers is the number halfway between the two numbers. That is just straightforward, right? In other words, it is the average of the two numbers. The arithmetic mean and the two terms form an arithmetic sequence, right? For example, the arithmetic mean between 7 and 17 is calculated as 7 plus 17 divided by 2. Okay, you should get 12. You can check with your calculator. And then this statement here is now saying the arithmetic mean and the two terms form an arithmetic sequence. Okay, so if you take these two numbers and then you get the arithmetic mean for these two numbers, which we got as 12, all these three numbers will form an arithmetic sequence. Remember, arithmetic sequence, common difference, right? So we have 7, we have 12, we have 17 there. If I look for my common difference, this T2 minus T1, I get 12 minus 7, which is 5. T3 minus T2, I get that as 5. So therefore, this is true. The arithmetic mean and the two terms form an arithmetic sequence. Okay. And then I just put this note down for you guys. Arithmetic sequences are also called linear sequences, where the common difference D is the gradient of the straight line, right? So basically Tn is that this can be written as Tn is equal to, I just brought this part to the front there. That will be Dn minus 1 plus A, which is of the same form as y is equal to mx plus c. Okay, this is an equation of a straight line. So we have our m there, we have our x there, we have d, and then we have n minus 1, and then we have our c there, and then we have our a there. Okay, so that's why they're saying d is the gradient of the straight line. So d would be our m. Okay, so next up, let us revise quadratic sequences. Okay, so a quadratic sequence is a sequence of numbers in which the second difference between any two consecutive terms is constant, right? So first, you're going to discover that the first difference is actually not constant, right? So then now you have to get the second difference. And if you get it to be constant, then there you go. You got yourself a quadratic sequence, right? So the general formula for the nth term of a quadratic sequence is Tn is equal to, wait, hold up. I see I just put an arrow there. It says square there. Remember, quadratic, it's something squared, x squared and stuff. Okay, so the general formula for the nth term of a quadratic sequence is Tn is equal to an squared plus bn plus c. Right. So let's just look at this part here. Right. So when n is 1, right? When n is 1, if we put 1 here, we get a times 1, which is a, b times 1, which is b, and then plus c. So this is where I got this from, a plus b plus c. I just substituted this one into this formula, right? When n is 2, I get 4a plus 2b plus c. Check that, guys. When n is 3, I get 9a plus 3b plus c. When n is 4, I get 16a plus 4b plus c. Right, okay. So now if I get my first difference, right, first difference, I'm going to subtract, I'm going to take this T2 here, 4a plus 2b plus c minus everything here, a plus b plus c. So 4a, I'll just quickly do this one here. So 4a minus the a will give me 3a, and then 2b minus the b will give me b, and then the c minus the c is 0. Okay, so you do the same thing for these ones here. Should get 3a plus b, 5a plus b, 7a plus b. And then now we want to check the second difference, whether it's constant or not. So do the same thing with 5a plus b minus this whole thing here, 3a plus b. So 5a minus 3a, I get 2a, and then b minus b, I get 0. And then I do the same thing here. You notice that these are the same, so that means it's constant. Okay, so I wrote that it is important to note that the first differences of a quadratic sequence, they form an arithmetic sequence, right? This sequence has a common difference of 2a between consecutive terms. So what this is saying here, right, what this is saying is the first differences of the quadratic sequence. So this number, that number, and that number, they will form an arithmetic sequence. That's why we're now able, from this arithmetic sequence that's formed here, we're now able to get the second difference. Okay, that's what it's saying. So this sequence has a common difference of 2a between consecutive terms. In other words, a linear sequence results from taking the first differences of a quadratic sequence. Right. Okay, so let's look at some nice examples. So it says find the nth term or the general term of example 1. So here's example 1 here, right? So we know the formula for the general term is Tn is an squared plus bn plus c. But then now they've given us these 4 values here. So we have 6, 13, 22, 33, and so on. Okay, so if I find the difference between these, right, for the first one, T2 minus T1, I get 7. T3 minus T2, I get 9. T4 minus T3, I get 11, and so on. Right, so I see this is forming an arithmetic sequence. And then if I get the second difference there, I get 2 here. 9 minus 7 is 2. 11 minus 9 is 2. Okay, so I see that this is the same. Yay! It's a quadratic sequence. Right. Okay, so then now I want to find what the values for A, for B, and C is, because I want the general term. So general term, remember guys what I say, general term has to be only in terms of n. That's the only variable that should be there, the n only. Okay, so now let's get the A, the B, and the C. Okay, so if we go back to this diagram here, so the first difference, our Tn, let's start here first, sorry. Our Tn is a plus b plus c. Our first difference is 3a plus b. Our second difference is 2a. Okay, so that means that this guy here, this 2 will be equal to the 2a. Okay, this 7 here will be equal to the 3a plus b, and this 6 will be a plus b plus c from that diagram that we did. Okay, so now you just take them separately. We have 2a is equal to 2. So therefore a is 1. And then now I have 3a plus b is 7. Remember I just got that a is 1, so I just put my 1 there. 3 times 1 plus the b is 7. And then this will be b. I take the 3. That side is going to subtract. I get b is 4. And then lastly I take this bit here to get what c is. I have a plus b plus c is 6. I just found b is 4 and a is 1. So therefore I just do the maths and I get c is 1. Right. So therefore the general term, remember general term, it only has to have the n variable and not any other letter. So Tn will be equal to n squared plus 4n plus 1. You just substitute. You take your A, substitute it there, your B, you substitute it there, and your C, you substitute it there. Okay. And then example 2, it says a quadratic pattern is given by Tn is equal to n squared plus bn plus c. That's the general term. Find the values of b and c if the sequence starts with the following terms. So they now want us to calculate what b is and what c is. Okay, you should already notice something here because they didn't ask what a is. So that means here we have a 1 times n squared. So that means a is 1. Okay, but let's just calculate it and see. So we have minus 1, 2, 7, and 14. Right, so we do the same thing. Minus 1, 2, 7, 14. You check the differences between them. We have 5. The difference between that, the difference between this one is, sorry, the difference between the first one and the second one, the first one is 3. This one, 7 minus 2 is 5. 14 minus 7 is 7. Yes. Okay, and then we check our second difference. We have 5 minus 3 is 2, 7 minus 5 is 2 as well. Okay, this now becomes 2a is equal to 2, 3a plus b is equal to 3, a plus b plus c is equal to minus 1. Okay, so guys, you need to know these, you need to know this, you need to know that, and you need to know that. Okay, so remember, let me just show you quickly this diagram. Please know it's this one. Okay, if you ever get stuck in the exam, what you can do is you know the formula, right? And then to get this value or this term here, you just need to substitute with n is 1, n is 2, n is 3, in case you get stuck and you don't remember this, that, and that. Okay, and then right, so then we have a is 1. And then now we have 3a plus b. 3a plus b will be equal to 3 there. Okay. Then if you do the math, you get b 0. And then if you do the math for c as well, you get c is minus 2. If you substitute, you should get Tn will be n squared plus bn plus c. It's equal to n squared plus 0n minus 2, which is equal to n squared minus 2. Okay, so now let's look at that example. This should be the last example for that part. So it says use the pattern 2, 7, 16, and 29 to answer the following questions. Find the nth term. Find the 9th term. In which position does the term 232 lie? Okay. So first, what we're going to do is, let's first check what the difference is. Is there a common difference, or is it a quadratic, arithmetic? What are we talking about? So the difference here, 7 minus 2, that's 5. 16 minus 7, that's 9, and then 29 minus 16, that's 13. Okay, so that means it's not an arithmetic. And then if we get the difference between the first differences, we get 4, right? So we have 9. We have 9 minus 5 is 4 there, and then we have 13 minus 9 is 4 as well. Okay. Right, so the first part, we have 2a is equal to 4, right? If you're not sure how we got this, just go back to the previous examples and use that tree diagram that we used that had 2a. This one, let me just quickly show you guys. This one here, this one that had 2a, that had 3a plus b, and that had a plus b plus c. Okay. So we have now 2a is equal to 4, and then therefore a is 2. Then we have 3a plus b is 5. We just got that a is 2. So that means that 6 plus b is 5, so b is minus 1. And then a plus b plus c is 2. If you solve, we get that c is equal to 1. Okay, so therefore the general term of the above quadratic number pattern is Tn is equal to 2n squared minus 1n plus 1. Right, so you just substitute. Where there is a, you put 2. Where there is b, you put minus 1. And where there is c, you put 1. And then in its simplest, so therefore in its simplest form, you just be Tn is equal to 2n squared minus n plus 1. Okay. And then part B says find the 9th term. Right. So now, instead of Tn now, our n is now 9. Okay. So what you're going to do is you're just going to substitute. Where there is n, you put your 9. So you have 2, 9 squared minus 9 plus 1, you get 154. And then for C, it says, in which position does the term 232 lie? Right. So the term 232. So this is our sort of nth term, right? So where there is Tn, you replace it with 232. This will equal 2n squared minus n plus 1, right? This now is a quadratic equation. Okay, let's just go back to how to solve quadratic equation from grade 10. Right, so we have, if I take this number here and I put it on the right hand side, right, it's going to subtract. So I have 0 is equal to 2n squared minus n minus 231, right? And then I work this one out in case some of you have forgotten. I did the SP, the sum and products, right? So I want to get, because it's 2 and minus 231, so I'll multiply these. I want the product of minus 462, right? And then I want the sum to minus 1n here, right? So I multiply these two. We have 2 times minus 231, I get minus 462. And then I want the sum, which is the minus 1n here, right? And then I look for factors that I would multiply to get 461, and then I'll also add to just get minus 1n, right? And then I got minus 22 times 21, that gives me minus 462, and then if I was to add those, I'll get minus n1. Okay, so awesome, that's what I want. Right, and then what I do now is I say 2n squared minus n minus 231, right? Just go back to factorization. This will be equal to 2n squared. Right, now where there is this minus n, I replace it with minus 22n plus 21n. So this becomes minus 22n plus 21n minus 231. Okay, and then I just group the like terms, so it's fine. I can leave them like this. It's 2n squared minus 22n plus 21n minus 231, right? And then I take out the common factor here, which is 2n, and then this side I'm left with n minus 11, right? And then plus here I take out 21, I'm left with n minus 11. Okay, and then now this becomes n minus 11 to n plus 21. So if you guys have forgotten how to do these, please just check with your grade 10 notes. Right, so this is now equal to 0 is equal to 2n plus 21 and n minus 11. So therefore, I get n is equal to minus 21 over 2, or n is equal to 11, right? Because this will be n minus 11 is equal to 0. So n is 11, or 2n plus 21 is equal to 0. So n will be minus 21 over 2, right? And then now, therefore, the 232 is in the 11th position, because the position cannot be negative or a fraction, so we cannot take this one here. So it always has to be a positive position, so that's what we're taking. And right now it's time for you guys to try those out by yourselves. Thank you for joining me today. Don't forget to come back for the next session. Next session we'll be looking at geometric sequences and series and so on. Okay, bye.
It's not a matter of whether or not we can. Everybody can, but not everybody will. How to turn nothing into something. How tangible are ideas and imagination? Ideas that become so powerful in your mind and your consciousness, they seem real to you even before they become tangible. Imagination that is so strong that you can actually see it. You can actually see it. If somebody cannot see it when it is not here, then it will never be here. Start looking into the future of what you would like to accomplish, where you would like to go, the person you would like to be. Decide what you want, and then act as if you already had it. And that is to believe that what you imagine is possible for you. So the first step is to imagine what's possible. Second step, to believe. Now here's the third step, and that is to go to work and make it real. You now go to work and make it a movement. You make it tangible. You make it viable. You breathe life into it, and then you construct it.
You have a lot to offer. The fact that you're still here means that your business is not through yet. People don't do what they know in life, but what they do is they operate within the context of the vision they have of themselves.
So write and draw and build and play and dance and live as only you can. Make up your own rules. The rules on what is possible and impossible were made by people who had not tested the bounds of the possible by going beyond them.
You must change what's possible for you. You, and only you, are the subject that impacts the burning desire in your imagination. You are living and feeling as if your future dreams are a present fact.
Will it be easy? No. Will it be challenging? Yes.
So you got to prepare yourself. You've got to develop yourself. Long as you're breathing, you got some more work to do. There's something else for you to achieve. Guess what? You're going to make some mistakes. You're going to make a lot of mistakes.
So now go and make interesting mistakes, make amazing mistakes, make glorious and fantastic mistakes. Break rules, leave the world more interesting for your being here. Make good art.
It is possible to start with nothing and become something.